it may sound like a paradox, one of the ways that psychologists have of understanding complex human behavior and the processes underlying complex human behavior is through the study of lower animals, and that is by the use of comparative methods. Now, the use of the comparative method has a long history in psychology when we consider the relatively short time that psychology has been a science. The use of the comparative method actually began with the ideas of Charles Darwin. Before Darwin, and his ideas made their impact on biological thought, students of behavior had considered that the differences between lower animals and man were qualitative ones. That is, that animals did not possess the qualities of mind and soul that differentiated man from all other living beings. Now, Darwin viewed both physical and mental development from an evolutionary point of view, and for him, the differences between man and lower animals was quantitative. To support this position, he maintained that man and lower animals have similar sense organs and similar instinctive responses, emotions, memory, and so on. Now, in an over-enthusiastic attempt to support Darwin's ideas, a number of psychologists and biologists began to collect anecdotal evidence to support the idea that the differences between men and lower animals were quantitative. And so they came up with the most magnificent stories. From this we have the ideas of talking horses. From this derive stories like Lassie and all these romantic animal stories that really have very little validity, but are most interesting to people who like to project man's ideas into animals. Well, the wealth of anecdotal material finally drove psychologists into the laboratory because they had to discover how animals actually behaved under controlled experimental conditions. And this led to the development of what we now call comparative psychology. Now, the idea of a comparative psychology is very distasteful for the individual who thinks that what this method does is to reduce man's abilities to the level of the rats. And in practice, the study of the behavior of lower animals actually has the opposite effect. For example, when Kathy Hayes reared a chimpanzee in her home from birth, Vicky, the heroine of The Ape in Our House, she reared the chimpanzee exactly as she would have a child. And despite all her efforts and despite the fact that the chimpanzee is capable of making all the vocalizations that the human being is capable of, that is capable of all the same phonemes, Kathy Hayes was only able to teach Vicky to say 3 words. And the chimpanzee was never able to put 2 of these words together to form a sentence. Now, when we understand the difficulties involved in teaching a chimpanzee a sentence and the impossibility of it, we are more than ever impressed with the ability, with man's language ability, with what differentiates him from the lower animals. But why is it that we use the rat so much in comparative psychology? And some of the reasons are simply practical. One of them is that despite the fact that the chimpanzee is much closer to man in complexity of brain and body, chimpanzees have to live in open spaces. They have to have controlled environment, and they're very expensive to handle. And in addition to that, they take a long time to reproduce. Now, anybody who's ever been owned by a cat knows that cats are not the ideal experimental animal, because you simply can't get a cat to do anything you want him to do. He does exactly as he pleases, and one of the things we have to do is to be able to control animal behavior. Now, the rat turns out to be the subject of choice because he's inexpensive, because he produces many generations during the lifetime of one psychologist. He doesn't require mammoth equipment, and he's capable of surprisingly complex responses. And now I would like you to see some of our experimental animals that we have here. First of all, I'm going to start out by showing you some of the babies that we have reared in our own laboratory. Now, one of the reasons that we rear rats in our own laboratory is that we then have complete control over the animal's experience. We also have control over his heredity. These rats, by the way, all of the ones here, including this one's litter mate, who's a little smaller, are hooded rats. Now, a hooded rat isn't a rat that has a hood over his head. He is the result of a cross between an albino rat that has rather poor vision and a wild black Norway rat that sees rather well but isn't very gentle and isn't very easy to handle in the laboratory. We breed many of our own animals for experimental purposes. Here we have a rat who has cannula implanted in his head. Now, cannula are small tubes. What happens in this case is that the animal is anesthetized, a flap of skin is cut back, a small piece of the skull is removed. Cannula are implanted in those brain structures that are considered to be important for study. For example, if we're interested in the chemical influences on a particular type of behavior, these tubes are implanted. Then they're covered, held in place by dental cement, covered with little screw caps. And when we want to inject a particular chemical, we simply unscrew the cap, put a needle into the tube, and inject a little bit of the chemical. We then see what influence this has on the animal's behavior. Here we have an animal who looks very well, is in very good health indeed, and as a matter of fact is a little too fat. This animal has had an operation, has had part of the ventromedial hypothalamus removed. The ventromedial hypothalamus appears to be one of the brain structures that is particularly concerned with eating behavior. Now, Whitey overeats, eats oftener than most other animals, and eats more when he does eat, and so has grown fat and large. Here we have another large animal. This is one of our good breeding males. He's getting old, but he is still able to produce many offspring, which makes him very valuable. When the rat is born, he is about the size of a little finger and looks very much like a little finger. Pink, no fur on him, and with tightly closed eyes. In about 3 weeks, in 2 weeks his eyes are open. About 3 weeks he starts to move around on his own, and he reaches maturity at about 90 days of age. Jason. And it is at this time that we usually introduce him to some kind of behavioral practice in the laboratory. I've showed you some of the methods, some of the ways in which we change animals so that we can get more information. There are many other things that we do. One of the things that we might do is food deprive an animal so that we are able to control his behavior. And we are then able to teach him, to help him to solve problems. And that, I think, is part of another story.